Hi, my name is Dolev, and I'll speak about augmented reality and how it changes the future of retail. Great, so let's start. And we'll start with a really short recap on what's augmented reality. So augmented reality is the combination of two domains. It's computer vision and computer graphics. We first need to understand the 3D world in front of us, and then we want to project or plant objects on the screen. So that was the recap. So what did we have before mid of 2017? So we had a few libraries you could have used. You had libraries that required anchors or clues in the real world. You could have used dedicated devices and software like Google Tango. And there was even closed gardens you couldn't even use. But all that changed during the big bang of augmented reality when Apple and then later on Google launched their two libraries, ARKit and ARCore, and they enabled two things. First, it was free and public, and it achieved state-of-the-art results on high-end devices. You didn't need any dedicated device. Okay, so a short explanation on who are we at Trax and where do we fit in the world of retail. So here's an example from one of our systems. This is a long aisle, and our challenge is to digitize it. What does it mean to digitize it? It means that we need to take the physical layout of the products on the shelf and transform them into a digital representation. Okay, so really understanding which product is located where and why do we even care about doing that? Because both manufacturers and retailers see a lot of value from this data. They can build a lot of business processes on top of this data. Cool, and we at Trax, we're working with the leading companies in the market, and enough about Trax. So just to set expectations straight, I'm going to talk about 3 projects that we have at Trax, which are involved with augmented reality, and the idea behind that is just to give you a taste on what can be done with technology today. Cool, so the first thing would be multi-perspective geometry. How do we stitch images together? So we have this long aisle, and we want to digitize it. So how can we do it? Probably the first thing that comes or pops into mind is why won't I just stand in the middle of the aisle and do a panorama? So what we'll probably argue is that it would be very hard to recognize those items on the edge. So that wouldn't be good enough. Probably a simple solution would be just take a few images and then stitch them together. But when you do this at scale and you see a lot of real-world images, you start to understand that there are 2 major issues. The first one would be you'll have issues with angles. The second is that you'll have missing areas. So how do we address these issues? First, let's talk about angles. Here's an image with an angle. What we do is we found a perspective transformation that changes the viewpoint so it would look like if the image was taken from a canonical front and parallel view. This is a trick we're employing before we do the stitching algorithm, so the stitching algorithm would have an easier life. So this is how we address angles. How do we address missing areas? So here augmented reality comes into play. So imagine a person, a sales rep, standing in front of a shelf, need to digitize it. So an augmented reality experience would be to give an immediate feedback on the areas that were collected and would be uploaded to the server. I'm saying that because our computation is done at the cloud. It's not down in the mobile device. And if we're uploading all these images not using this AR view, we'll have an issue of fixing the missing areas when we're already at the cloud, and that's not possible. So here we can just give the immediate feedback, the immediate experience of collecting images and then fixing issues on the fly. Great. So what we've seen so far, that's the first project. That's a product, it Trax. It's already used with users around the world. The 2 additional projects we'll see now are in the research phase. Okay? The first one is Store Mapper. How do we map stores at scale? And what do I mean by mapping stores at scale? Part of the digitization effort is not just looking at aisles, it's also generating the physical layout of the entire store. So we want to generate maps of all stores and enrich this data in addition to that, with layers of, for example, categories, which category is located where, where's the entrance, where are the cashiers. This data could unlock a huge potential of value. This is just a data source. I haven't spoken about applications. An example of an application would be if I can correlate sales data with the relative length of a category from the entrance, for example. How does it affect sales? For example, if the milk category is close to the entrance or further away, how does it affect my sales? How does it affect sales of other categories? So this is a data source. It could be used for many applications. We'll see an additional application later on. So how can you do it? So at Trax, we're working with robots. We can send a robot to map the store. The robot, for its other purposes, has inside of it actually a map for indoor navigation for the sake of the robot. But we can reuse this data source and use it for our purposes. I have to say, small thing about that is, while robots are definitely the future, they're not the present. It would be very hard to scale this to a lot of stores. So what would be a solution? What would we do differently? So we're gonna combine 3 pillars. The first would be augmented reality to generate the map of the store. The second would be deep learning on device, not on the cloud, in order to generate the categories, the layers of data. And the third would be utilizing crowdsourcing. Let's see a short video on that. So a person walks in the store, and as they walk, the map is starting to appear, and also categories as well. What's important here is not the AR experience. We're not aiming for an AR experience, but using the SLAM from the AR session in order to generate the map and simultaneously run models on the device. So we send our engineering team and ask them, go and map a store in Israel, and that was a typical result. But things change when you go at large scale. So first of all, how do you even achieve large scale? For that, luckily for us, Trax acquired a company named Curie, and Curie was already sending people, the crowd, to do shifts at retail stores. They would go and take images of categories. But then you can really use the huge potential of the crowd being deployed everywhere. And what we started using at research is sending them to do special operations. We wanted them to do just not taking images of categories, but sending a crowd member, here use an augmented reality application and map us a store. And these were the initial results. I would argue this looks much more like an artwork than actual map, but this is the reality of every research project. You start and you need to understand what's not working. So we understood that using augmented reality for large areas has its issues, especially with drift. The AR session could have issues understanding the world. For example, if another application is using the CPU, you'll immediately see issues with drift. So how do we tackle such problems? First of all, we develop our own proprietary debug tools. This is not a simple application where you have buttons and drop-downs and you can press them and have a debugger then later on understand what was the problem. It's someone traversing through a store. How do you understand what happened when the drift started occurring? So we started building these AR visual models, and after a few rounds where we sent the crowd, found issues, sent the crowd again, we finally started seeing some good results. This is an example of a store next to Chicago where we sent someone, I don't know who, and they generated that map for us. Okay, so this was the second project. That was a proof of concept. By saying a proof of concept, I mean this is something we are pushing towards production, towards becoming a product at Trax. And now we'll discuss a demo. So a demo would be a demo of the shopper. As I said before, we're working with manufacturers and retailers, but we're not addressing the shopper, you. So in the long vision of Trax, we're aiming also to provide a new experience for the shoppers using augmented reality. So how would we do that? We're going to combine and fuse together a lot of technologies. One of them will be the maps that we generated before, not the 2D maps, but 3D maps, which you can generate from the point cloud that the device takes, and then someone else can utilize that same session to navigate at the store. We'll use mounted cameras. Cameras we mount on a shelf and take images of the opposite shelf as well. And what you see here is someone building a list of items, and then you'll see the augmented reality shows us the exact items we want to purchase. So we selected a few items. What you see here is a substitution. You can see below the target on the product we want to purchase, and maybe a coupon saying, you know what, we don't have the product you want, we have another product, get this one in 15% discount. Okay, so let's see a short video. This is how we vision this new experience. A person entered the stores, he opens the application, he then selects the products. You can see already the augmented reality sign hovering up because he wants the coffee category. Here's the robot. Then he navigates towards the coffee category. You see an arrow pointing on the back, the distance. These are the mounted cameras, fixed cameras that digitize continuously. You see the breadcrumbs on the floor pointing him towards the location. And you'll see very shortly, here's the targets appearing on the screen. This is the product you selected. You can see it here. You can take it, grab it, maybe see another coupon. Scan, and eventually even you'll see in a second pay. I think the interesting thing about that is that we bridge together the online world into the offline world. You start seeing interactions which is much more online. You can see maybe what your friends like, didn't like. You can augment a lot of things on the shelf using that. So the online comes to the offline world. So in this short conversation, we had the chance to look on 3 different projects in different phases of maturity. And what I hope this talk gave you, if in any chance you think that you are working with mobile devices or you think that it's something that could help you, augmented reality is mature enough, and I hope it will give you the confidence to try it out. It has its challenges, but it's still something worthwhile testing. And I also think that augmented reality is definitely changing our reality, and you'll start seeing that probably more in the future. So thank you very much for your time. If you have any questions, I will be happy to take them.